Hello everyone. Today we're going to learn about the program development cycle. And the goal of a program development cycle is not just to make a working executable or program, but to make it well, both on the front end and the back end. The front end would be from the user's perspective. Is it buggy? Is it annoying? That sort of thing. And then the back end is from, well, is it hogging too much memory? Am I lagging too much with this? What is am I doing things that I don't even need to do to make this program work? So this cycle is to help generate the both sides correctly. And some people would even throw in elegant programming, that sort of thing. Um, Basically, we just want it to work and work well. Just like if you make a chair, you want to make a chair that works, that looks good, that feels good, all the things you expect from a chair. Well, if we go in and program right away, which, to be honest, if it was up to me, I'd do that all the time. But I also know that if I do that every time, I might go down an avenue that ends up in a dead end street. I might make something that people would never would want to use. So instead of making the world's worst program, let's back up and let's start off with these rules, or these steps is probably a better idea. The first step is, as you can see, the golden rule, which essentially breaks things down into three simple pieces: input, doing something, output. That is what a program should do. So if I add 5 numbers together with a program, the output is going to be the sum. The process is going to be the adding. The input is going to be the first 5 numbers. If we have a super huge, convoluted, big program that does 10,000 things, these 10,000 things can be broken down. You're constantly breaking things down until you get into these 3 simple rules of program. So let's figure out what we want and let's go for it. And now that we have this kind of the basic breakdown of what we want to do, we go and design. And this is kind of new to programmers, because a programmer in the old days, you'd make a text-based program, make it on a command line prompt, and you'd run it, and then somebody would type in text into it, and then hopefully they typed correctly. Because if it was even one letter off, it might not error catch, and all of a sudden you've got something that doesn't work. Now, however, programmers have to think of it, and that's why we've kind of turned into developers now as opposed to just pure programmers, that we actually have to think about the way things are laid out. Where do we put the start button? Where do we push the play button? Where do we put the files, etc., etc.? So what I want to use is just a simple example of this, and I'm going to bring up any one of these guys. The simplest one might be this guy, so I'll give Audio Converter Studio, get a little free pub today. I'm going to cancel out of this, but here is its basic GUI, its graphic user interface. Not a lot of text. If I want something, I want to go to just click on a tab and have it go. Or if I want to go into a folder, I'll double click and I go into a folder. So we have all this programming that does this behind the scenes, and the programmer, or the developer as we're going to call them now, is in charge of that, and they have to make it user friendly and a little bit obvious, or what some people would say intuitive. We will talk about the form sketch next, but that is essentially the layout of the design. So look for that in the next video. Okay, so now we designed it. We've designed a nice GUI interface, and we want to come up with the program logic. This still does not mean that we are going to write the code out. As you can see, that's number 4. We're going to use something called Pseudocode and Flowcharts. Again, this is going to be on a separate video, so watch it. But basically what it says is, before I write it in C#, let's write it so I can write it in any language, and it makes sense. And then once you kind of get all those kind of basic logic and logic errors out, then you can go and write the code. Now, once you're done with the code, chances are, you might have fumbled something and hit the wrong button, and so you might have incorrect syntax. Remember, these are called languages for a reason. So just like we have periods in English, there we're gonna see semicolons in C#. When these problems go awry, you catch them, you do the correct punctuation, like I was saying, and also we have words that actually mean something. There's always these reserved words, and there's words that we can create in C#. We'll talk a little bit more about those in future ones, but that's what we're going to do. We're just going to correct the very basics so now our programs can compile. And once we compile them, we go and look for logic errors, because just because a program runs doesn't mean it's doing it correctly. So let's say you're adding those 5 numbers again. If you add 5 plus 5 plus 5 plus 5 plus 5, and it comes out with 23, now you have a logic error. What went wrong that it didn't add it to 25? Now, if I had my way, I'd put testing on here at this point. And by testing, not test for logic errors, I would actually say user testing, meaning getting it away from the developer. So when I think of logic errors, I usually tend to think of we creating it, but you can obviously create it, put it out to everybody, or just a test group, or just a bunch of alpha or beta users, and see if they can come up with any problems. The thing here is, though, and the reason why I say it could be an extra step is it really should be done at both places. So in other words, people who use your program are more likely to find errors that you aren't naturally going to look for as a developer, and possibly vice versa. So having those two groups really works. And that's pretty much it. That's it for a simple program development cycle. We could talk about agile and waterfall and all this other stuff. This is kind of just like a nice, simple way of doing it. And this is probably how we'll approach it most of the time here in these videos.